Hello everyone. Hi Afreen. Hi Rayan. How are you both? Can you hear me?
Yes, ma'am.
How are you?
Fine, ma'am. How are you?
Yeah, I'm also good. Introduction to trigonometry we were doing. The third exercise, I mean the last exercise we were doing, where most of the students feel that this exercise is quite challenging. Do you also feel the same? Have you tried solving questions from here? The third exercise.
Yes,
Is it confusing? Is it complicated? Or you understand the concepts, you know how to do the proofs and all?
ma'am, some questions are tricky.
Some questions are tricky. Okay, let me take. Uh, there are some 98% or maybe 95% of the questions you will be able to just do it by just converting everything in terms of sine and cos, then whatever simplification and calculation is coming on your way, if you will keep on doing, automatically you will land at the proof. But yeah, there are some 5% question where trick is required. I'll be taking those questions in today's class. Just a second, I'm sharing the screen. Just a moment now. Yeah. Here, question number 5. Okay, question number 5. When you will do question number 5, it require a certain trick. Okay, we need to use a certain trick to do it. Let's do. Here we are having cos A minus sin A plus 1. I mean the subpart 5. Okay, can you see 5 over here? Can you see the screen?
Yes, ma'am.
Yes. Okay. So this 5 require a certain trick. Otherwise, all the questions from here, you just need to do whatever is coming in your mind. Any simplification, addition, subtraction, whatever. Okay, you can see in the question or is coming on your way, you will be doing it and you will end up getting the answer. What I'm talking about, if that is not making sense, let's see. First of all, I'm going to take number 5 over here. Cos A minus sin A plus 1 by cos A plus sin A minus 1. That this one is equals to cosec A plus cot A we need to prove. Now we will be using a trick over here. What we can do, since we want to prove this left hand side is equals to the right hand side, that is cosec plus cot. I'm trying to get cosec and cot on the left hand side. Okay, so for that I have to divide. See, in numerator you are having cos, but you don't want cos. You want cosec or maybe cot. Okay, so if we will divide the numerator, by cos and the denominator also by cos, let's see what are we going to get. So we are going to divide the numerator. Okay, when we will divide the numerator by cos, okay, or maybe sine, let's see what can we do. If you will divide the numerator by cos, cos by cos will be 1, sine by cos will be tan, and 1 by cos will be sec. So we are going to get tan and sec. Can you see, if I'll divide the numerator by cos, this cos by cos, sine by cos, and 1 by cos will be having this all term 1 by 1 I am dividing by cos. Can you see? So we are going to get 1, we are going to get tan, we are going to get sec. But I want cosec and cot. Okay, so this cos is not helping. We need to do the division by sign. If still you are having the confusion, let's check it. When you will divide this numerator cos minus sine plus 1, when you will divide it by sine like this, okay, a is here, a is here, sine a, you will be getting cos a by sine a, okay, by separating the term, which is cot a. Sine a by sine a, that is 1, and 1 by sine a, that is cosec a. Making sense?
Yes, ma'am.
So what are we trying to do? We are just trying to get the terms as a cosec and cot. Okay, here we are having sine, cos. This is that particular question where we need to use a specific trick, and the trick is first convert it, this all the sine and cos, just write it in terms of cosec and cot, and easily we will be able to do so by dividing numerator and denominator by sine. Is it allowed in mathematics to do the division in this manner? Oh yeah. Okay, we can always multiply the numerator and denominator of any fraction by by a particular number, or maybe by a particular term. Okay, we can multiply numerator denominator by x, we can divide numerator and denominator by x. So if we are allowed to divide numerator and denominator by x or maybe by y or maybe by z, then we can also divide it by sin a or maybe by cos a. Okay, this is completely okay. Where a is a specific angle, okay, and same thing we are taking in numerator and denominator. That way we are not disturbing the fraction, we are just taking the equivalent version of the same fraction. Making sense? Making sense?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
we are dividing numerator and denominator by sin a. The moment you will divide numerator and denominator by sin a, your numerator will be cos a by sin a minus sin a by sin a plus 1 by sin a over the denominator cos a by sin a plus sin a by sin a. Actually, we are dividing at first completely. Then we are separating the term. Okay, term by term we are taking. So sin a by sin a minus 1 by sin a. This way we are doing the division. Okay. Now our terms will change and it will become, the numerator will be cos by sin, that means cot a. Sin by sin will be 1 and 1 by sin will be cosec a. Denominator will be, this cos by sin will be cot. Sin by sin will be 1 and 1 by sin will be cosec. Is it clear so far? Why are we doing it? We are just looking at the RHS and hence we are doing it. Is it making sense to all of you?
Yes, ma'am.
Okay. Now what can we do over here? This is the trick which we are going to use over here. The trick is, we will be using the identity of cos, cosec and cot. The identity which you have learned was cosec square theta minus cot square theta is equals to 1. So the 1 which I can see in the numerator, no, at the place of that 1, I am going to write that cosec square a minus cot square a. Okay, the 1 which you can see in the numerators part, that 1 I am going to replace with cosec square a minus cot square a. Okay, for now I am going to write this way. The numerators part which we are having in hand is cot a plus cosec a plus 1. Okay, I'm just writing one aside and then I'll replace this one. Okay, if you will ask me why are we doing it, how you will get to know. So see, I told you this is that this falls under that 5% or 3% question where a certain trick we have to use. Okay, by looking at the question you won't be able to understand that, yeah, let's see, addition is there, let's do the addition, or maybe subtraction is there, let's do the subtraction, or maybe this formula we can use the algebraic identity. Okay, so let's use the formula. This is not that question. However, after this one we'll be doing those questions where I'll not tell you that you are supposed to do this particular step. Okay, so this trick we need to use over here and then only easily we will be able to prove. So cot a plus cosec a, and this one I am going to replace with the identity. See, at the place of 1 I'll be writing the identity, that is cosec square a minus cot square a. Making sense?
Yes, ma'am.
Yes, ma'am.
Over, we are not going to disturb the denominator. Let's keep the denominator as it is. Cot a plus 1 minus cosec a. Now the numerator, okay, we have written cosec square a minus cot square a. Does it looks like a square minus b square, or maybe x square minus y square, which says that a plus b in one bracket and a minus b in another bracket? So for this cosec square a, if you are thinking how can we write that, okay, so cosec square a means cosec a complete square. Cosec a complete square, this is just a way of writing it, cosec square a, but actually it is cosec a complete square. Okay, so if we understand that, then we can write it as a in one bracket cosec A plus cot A, and in another bracket cosec A minus cot A. Yes or no?
Yes, ma'am.
That is equals to 1. So at the place of cosec square A minus cot square A, I am going to just use the formula. Okay, A plus B in one bracket, A minus B in another bracket. Or if you have learned like this, x square minus y square is x plus y in one bracket, x minus y in another bracket. We are going to use the formula. Okay, why we will use the formula? Just a moment, let me show you why we are going to use the formula. Can you see this blue colored bracket part?
Yes,
Can,
ma'am.
if you will use the formula over there and do the expansion, there also one of the bracket will be exactly like this. Yes or no?
Yes, ma'am.
Okay. So you are going to have over there you will be having cosec A plus cot A in one bracket, and in another bracket cosec A minus cot A. And the denominator we are not going to disturb at all. Now you just need to take out the common factor and you will be done with proof. Now you just have to take out the common factor. I am telling you that this is one of the term and those are another term. Okay, this all together are another term. Can you see there something is common? If you are not getting, then I can tell you that suppose I am assuming for now you can I'll just rub the initial part. If you have not copied yet, please copy it. Can I rub the initial part?
Yes.
Okay, I'm rubbing it. Wait. So we were having, just a moment, no, all got deleted. We were having cosec A plus cot A, and we were having plus cosec plus cot in one bracket and cosec minus cot in another bracket. And in the denominator we were having the denominator which we have obtained, that was cot A plus 1 minus cosec A. Yes or no?
Yes,
I
ma'am.
want to I want you to notice that can you see this is the common factor over here. This is the common factor over here. If you want you can assume, just for your clarity I am showing you. If you understand directly then that's the best. But let me show you this way. Let this one is k. Let this bracket where cosec A plus cot A is k. For now, I'm going to call that the bracket where cosec A plus cot A is there. Let's call it k. Okay. Then the first term will be k. Plus next will be k into cosec A minus cot A. If now I will ask you what is the common factor over here, will you tell me that k is the common factor? Yes or no?
Yes, ma'am.
Okay. So that's why if directly you understand that cosec A plus cot A is the common factor, you can take it directly. And if directly you end up getting confused always that why it is written in the book, or maybe why I'm telling you that this cosec A plus cot A is the common factor. Two terms are there and this is the common factor. Always it creates confusion. Then you can do it this way. The moment you will take it as a k, you can clearly see k is the common factor in the numerator. Okay, and what about the denominator? We'll maintain the denominator as it is. We are not going to disturb it at all. But the moment you will take k as a common factor in the numerator, you will end up having 1 plus the bracket. In the bracket, you were having cosec A minus cot A. And the denominator still you are keeping as it is. That is cot A plus 1 minus cosec A. Now, when you will simplify the curly bracket part, little bit when you will do the simplification, Just the curly bracket part. K, just keep it as it is. It is 1 plus cosec A minus cot A. Okay, nothing you have to do the simplification over here. Even opening the bracket is still really easy because plus sign is outside the bracket. So you don't have to do any changes. Cot plus 1 minus cosec. Wait, am I writing something? We are dividing by sign. So this will become cos by sine was cot. Sine by sine was 1 and 1 by sine was cosec. Just a second, no? I think I have written something else. Can you have you copied? Can you check the same sign? Have I taken the sign incorrectly? Was there negative sign over here or what? Anyone? Here it was negative or what? Let me check it. We were having cos by sine, that is cot. Sine by sine, that is minus 1. Oh yeah, minus 1 was there. Okay, in the numerator. It was minus 1. I can show you cos by sine was cot. Sine by sine was minus 1 and 1 by sine was cosec. So in numerator it was cot A plus cosec A minus 1 was there. It was not plus. So in between negative sign was there. Yes or no?
Yes, ma'am.
Okay. This was negative over there. This sign was negative over there. You have to open the bracket carefully now. Because my the solution, all the solution was there in the other screen, and by mistake I have deleted everything. Okay, here minus sign was there, minus cosec it will be. Okay, and minus cosec plus cot will be there. Is it making sense, the curly bracket part?
Yes, ma'am.
Now, when you will compare your curly bracket and the denominator is ditto same, exactly same, please match it. One positive in the curly bracket, one positive in the denominator. Cosec A is negative in the curly bracket, cosec is negative in the denominator. And cot is positive in the curly bracket, cot is positive in the denominator. The curly bracket part and the denominator's part is exactly same. Can you see that?
Yes, ma'am.
Yes, the terms are written
Yes, ma'am.
here and there, but integer chapter you have learned, and there you have realized that doesn't matter if the terms are sitting here and there, we just need to check the sign. Okay, if minus x plus y is there, or maybe y minus x is there, these two are the same thing because they are also negative x, here also negative x, they are positive y, here positive y, these two are exactly the same thing. Yes or no?
Yes,
Right?
ma'am.
Okay, so this curly bracket is exactly same with the denominator, hence cancelling each other, and we are just left with k. We have taken the assumption that k is cot A plus cosec A. So we can replace it back that k means cot A plus cosec A, and we are done with the proof. Can you see that?
Yes.
So in this question, again, I'm telling you, I'm going to rub everything and I'm going to explain you from the beginning. I'll be summarizing what you have to do in this tricky question where a certain trick is required. Okay. In this question where you are having cos A minus sin A plus 1 by cos A plus sin A minus 1. And the other side is cosec plus cot. Okay, exactly like this. One more question is there which is there in the example part. Okay, in your example exactly a question is there which is exactly like this. So first of all you have to see the left hand side and you will try making it cosec and cot in the left hand side. Whatever is there, cos, sine, we are trying to convert it in terms of cosec and cot. For that, maybe we have to divide it by sine, or maybe we have to divide it by cos. That you can check it in the rough part, that if we will divide the numerator by maybe sine, or by cos, so the numerator will be cos by cos. Okay, I'm talking about this numerator, cos by cos. Other term will be sine by cos, and the other term will be 1 by cos. If we are dividing by cos, okay, it will be 1, sine by cos is tan, and 1 by cos is sec. So no, we don't want to generate tan and sec. There are questions where you have to generate tan and sec, and that time you can do the same thing which I am showing you. Okay, so we are not going to divide the numerator and the denominator by cos. Okay, we will be checking with sine, that what if we will be dividing the numerator and the denominator with sine. Okay, sine, 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 sine. So cos by sine cot, sine by sine 1, and 1 by sine cosec. Yeah, we can divide it by sine. So from here we are getting the clarity that this is how we can get the terms cosec and cot in the left hand side. The moment you are able to make it cosec and cot, the moment you are getting that this became cot minus 1 plus cosec a, and the denominator also you are converting accordingly, so it became cot plus 1 minus cosec. Now you don't have to disturb the denominator. Okay, it must cancel it out. Why? Because in the RHS we don't have any denominator and all. So here the best possible way to just deal with it is denominator. If the denominator will cancel out, okay, or the denominator will get cancelled out, that will be the easiest way, okay, to get the RHS. So we are trying to cancel out this denominator, and for that we are, for now we are not going to touch the denominator, we will keep it as it is over here. We need to work on the numerator. Now how we will work on the numerator? So we will keep this cot and cosec together, and 1 we are going to use identity. 1 at the place of this 1 we are going to use the identity. We are going to keep this cot a and cosec a together, and at the place of 1 minus 1 we are going to use the identity, that is cosec square a minus cot square a. Now cosec square a minus cot square a, not only in this particular question, in this exercise very often, okay, sine 1 minus sine square a, or maybe 1 minus cos square a, this type of term, no, or very often you will be writing the identity, you will be using the identity a plus b in one bracket, a minus b in another bracket, or maybe you call it x plus y in one bracket, x minus y in another bracket. We are not doing it specifically for this question. Okay, very often you will be doing over here these steps. Okay, so you have to keep in mind that if you can see this type of thing, maybe we can expand it. And here the moment you will expand it, writing cosec plus cot in one bracket and cosec minus cot in another bracket, now you have to take out common factor. I have seen so many times student end up getting confused. When I say please take the common factor, they think that from where we must take the common factor. So see, I am telling you to take the common factor by just seeing two terms over here. If the two term, that logic is not clear to you, that you then you can assume that cot a plus cosec is k. Okay, this is completely k, and here you are having k into something. Now you will be able to see, okay, k is the common factor. Okay, and the moment you will take out k as a common factor, you will open the bracket, you will be getting the remaining part which will cancel out the denominator. You are done with the proof. Clear?
Yes.
Okay, so this question number 5 requires a certain trick, and this is the trick to take one as an identity. Okay, there are so many questions which are exactly like this. So whenever you see questions like this, left hand side cos sine is there, other side tan plus sec is there, or maybe cosec plus cot is there, or maybe tan minus sec is there. Just think about like this particular approach, also keep it in your mind. Okay,
Yes, ma'am.
now let's do the next questions. We are having question number 7. Okay, sine theta minus 2 sine cube theta over 2 cos cube theta minus cos theta. I told you that that is the one of the question where a specific trick is required, and I'll not repeat the same sentence again in any of the question over here. So just after looking at this question, can you, is are you feeling that we can take common factor from the numerator and we can take common factor from the denominator? Yes or no?
Yes.
Okay, so if we will take common factor from the numerator, it will be 1 minus 2 sine square theta. And if we will take common factor from the denominator, we'll be having 2 cos square theta minus 1. Now we will see what exactly we have to prove. So we have to prove tan theta. And I can see already this sine by cos is making tan. That means if the bracket term will cancel out each other, okay, then we will be done, right?
Yes, ma'am.
Yes, ma'am.
And how can we do so? By making them both same. We will try maintaining both of them, yeah, either sign in terms of sign or both of them in terms of cos. How? By using the identity. The bracket part where the numerator is having 1 minus 2 sine square is there, and the denominator 2 cos square minus 1 is there. We will try maintaining both of them, either sine or either cos, by using the identity. Is it making sense to both all of you?
Yes, ma'am.
Yes,
Okay,
ma'am.
so if you want to maintain the numerator or maybe the denominator, let's maintain the denominator. Okay, so if we will try maintaining the denominator, this denominator cos, I don't want cos in the denominator, I want to convert it in terms of sine. Okay, so this cos square theta, I'm going to write at the place of cos square, I'll be writing 1 minus sine square theta. Is it making sense?
Yes, ma'am.
Okay, so the
Yes.
numerator as it is I'm writing, of course outside the bracket sine by cos. The denominator at the place of 2 I am keeping as it is. At the place of cos square, I am going to write 1 minus sine square minus 1. Okay, let's do sine by cos as it is. I am copy pasting. The numerator I am copy pasting. The denominator, I'll open the bracket carefully. So it will be 2 minus 2 sine square theta minus 1. 2 minus 1 is 1. Okay, can you see the denominator became 1? 2 minus 1 is 1 minus 2 sine square theta. The numerator's bracket and the denominator's bracket became exactly same, which can cancel out each other, and we are done with the proof. Already we were having sine by cos, right? Are we using any trick?
Yes, ma'am.
Then how we are doing the proof? The question is guiding us. Question is guiding us that just first of all we were looking at the question and we were thinking what to do. Is there addition, subtraction, okay, or maybe any formula we can apply? Which formula? The formula which you have learned in the previous class, x plus y whole square formula, x minus y whole square formula, x square minus y square formula, or any of the formula from there, or maybe three identities which you have learned over here. From all this formula list you are checking, can you use any formula? So first of all, I was just looking at the question and I realized that for now I can take the common factor. The moment I have taken out common factor, we realize the sine by cos already coming. Then why this bracket part? Why this bracket part? And believe me, the question is designed in such a way automatically it will cancel out each other. We just need to think about it, that let's make the numerator and denominators bracket same. Either you want to maintain sine, please maintain it. You want to maintain cos, maintain it. It will cancel out each other. But while maintaining cos or maybe sine, your simplification needs to be clear. If you will end up doing mistake in the symbol plus minus sign while opening the bracket and all, then you won't be able to cancel it out. Is it clear, the proof? Anyone having any doubt over here? Yes, Afreen, is it clear? Inan, is it clear?
Yes, ma'am.
Okay, let's do the next few questions. We are done with 5. We are done with 7. 6 I have not taken still. 6. 1 plus sign. 1 minus sign is equals to ck plus tan n. Right hand side, we can take any of the side, either left hand side or right hand side. But in most of the solution, we always try taking left hand side and we try reaching to the right hand side. If we
Ma'am,
cannot do anything at all, yeah.
this question came in my previous exam. So while I was doing this question in textbook, actually it was don't know. Then I googled it, and they only multiplied one one minus sine a in the left hand side, and they got it.
Yeah. Okay. Why we are going to do so? See the left hand side. I'm going to take the left hand side because in most of the question I'm taking left hand side only. Okay, if I cannot do anything at all with the left hand side, then I'll be thinking about taking right hand side. So
Ma'am,
if
your
I'm
voice is
taking,
not audible.
yeah, what? We will be taking the left hand side. And after looking at this left hand side, I can see on the right side, there is no
Ma'am,
square
your
root.
voice is not audible.
Am I audible? Can you hear me, everyone?
Yes, ma'am.
Yes, Rayan, can you hear me?
Yes, ma'am.
Inan, please check your connectivity. If you can't hear me, you can once leave and then rejoin. Can you hear me, Inan?
Now I can hear you, ma'am.
Okay. So we are having one under root this by that. Okay. When I'm looking at this LHS, I can clearly see in RHS root is not there. So first thing which is coming in my mind that anyhow, if I'll remove this root, that will be great. But how? How we will remove the root sign? So rationalization you have learned, and there you have learned that if you are having root like 1 by, let's say, root 5 plus 3, what you used to do over there, you used to multiply the numerator and the denominator with root 5 minus 3 and root 5 minus 3, right?
Yes, ma'am.
Okay, so something like that will be useful over here. What we can do, see, 1 minus sign we are having in the denominator. Okay, if I'll multiply the numerator and denominator, just see carefully. If I'll multiply the numerator and the denominator by 1 plus sign, 1 plus sign, and that too I'm going to do the multiplication inside the root. Okay, inside the root I'm doing this multiplication. Inside the root we are going and doing the multiplication. Is it allowed? Again, I'm telling you, in any of the fraction, even that fraction is sitting inside the root or whatever, if you are multiplying same number in the numerator and denominator, that way you are not disturbing the fraction. Or same term, if you are multiplying in numerator and denominator, that way you are not disturbing the fraction. Okay, so we are, if we are multiplying like this by going inside the root part. Okay, for example, if you are having under root, let's say root 3 by 5, and if you will multiply here 2, here also 2, it will become root 6 by 10. Still this root 6 by 10 means 3 by 5, yes or no?
Yes, ma'am.
Okay, so that way we are not disturbing this fraction. Inside the root we can go and then we can multiply it same number, same term in the numerator and denominator. Or maybe we can divide by the numerator and the denominator by the same number. Okay, this is completely okay while dealing with any of the fraction. But the question is, will it help us removing the square root sign, because we don't need this square root sign at all. So just check it carefully. The moment you will do multiplication like this, your numerator will be 1 plus sine a complete square. Clearly we can see the square root term will get vanished from the numerator. And what about the denominator? The denominator will be x square minus y square, something like this. So numerator is still, we can see clearly that yeah, root sign will vanish. But denominator is still, we have to see what can be done. So you need to understand your denominator will be 1 minus sine square a, which is according to identity number 1, sine square theta plus cos square theta is equals to 1. And from this one rule, the two more version of the same rules exist. That is sine square theta is equals to 1 minus cos square theta, and cos square theta is equals to 1 minus sine square theta. These all are the same rule, just different version but the same rule. Can you say? So when 1 minus sine square we are having in the denominator, can I write it as a cos square by using the identity number 1? Yes or no?
Yes, ma'am.
The moment you will write it like this, your denominator is square root sign will also vanish. So first thing first, we were thinking how to remove the square root sign. When we use the concept something like the rationalization, okay, we can see automatically identity is helping us. And yeah, our square root sign at least is getting vanished from the numerator and as well as from the denominator. But the confusion is, are we done with the proof? So yeah, we are done with the proof. 1 plus sine a by cos a can be written as 1 by cos a plus sine a by cos a. Automatically, we have landed at the proof. Can you see that? You will be able to solve these questions, okay? Or maybe the question like this directly in your exam when you will practice enough at your home, when you will practice these questions from ncrt, each and every example from ncrt, and many more questions from pyq, then only you will be able to think about a new a very new question will be there in front of you, and you will be able to use the logic. Maybe root will be there and maybe the same logic we can use over there and it will work. Making sense?
Yes, ma'am.
Okay, if you are
Yes, ma'am.
thinking that you will do only these questions and you will be able to solve a new question, no, you will not be able to do any new question if you will solve only these questions from ncrt. You need enough exposure. You need to, there will be moment when you will start the pattern getting, okay, started getting like the same pattern, it's coming again and again on your way. Yes, the questions are different but the same format again and again you are using, okay, then only you will be able to solve new question. And yes, okay, it's not really vast, there are limited way to deal with such questions. See here, 1 plus sine a by cos a, 1 plus sine a by cos a, very often we are separating the term, right? 1 by cos plus sine by cos, yes or no?
Yes.
Okay,
Yes,
and
ma'am.
the formula, that is sec square theta minus tan square theta is equals to 1. Formula you have learned. Two more versions are there for the formula, that also you know. You also know that the formula sec square theta minus tan square theta can be written as sec theta plus tan theta in one bracket and sec theta minus tan theta in another bracket, right? Just like the formula a square minus b square, or maybe x square minus y square, right? Right. So these are the steps which we are repeating in this chapter in almost like every second question. Let's do a few more. Is it clear, Inan, now?
Yes, ma'am.
Okay, let's see the next questions. We are done with 4. 4 we have taken? No, I don't think we have taken 4. 5 we have taken, 6 we have taken, 7 we have taken, 4 we have not taken. Let's take 4. In 4 we are having 1 plus sec by sec. Always I work with LHS only. Okay, if I can't do anything with the LHS, then only I think about taking the RHS or solving LHS and RHS one by one. Okay, so first of all, we are taking LHS and we are going to solve it. While solving LHS, I am looking closely what can be done with the question, what can be done with the question. Now I can see one thing I can do, I can convert everything in terms of cost, right? Right? When we don't know anything, we always what we do, we convert everything in terms of sine and cos. Okay, so let's convert. Then why we have used that particular approach in question number 5? Because question number 5 was a special question. So for that we will not be talking that why we did or what we did. Why not we thought about these steps in question number 6? Because already everything was in terms of sine. Okay, in question number 7, because already everything was in term of sine and cos. So when we don't know anything, first of all, we will convert everything in terms of sine and cos. So 1 plus sine sec A will be 1 by cos A, and divided by sec A will be 1 by cos A. Then the numerator, now I can see we can do the simplification. So the simplification in the numerator, when we will do LCM, will be cos A, and the numerator's part will be cos A plus 1 divided by 1 by cos A is there. Is it clear so far? Is it making sense?
Yes, ma'am.
Okay, then we will just try simplifying, and we will end up getting cos A plus 1 by cos A into cos A by 1. I'm just doing the simplification. Okay, division can be taken as a reciprocal fraction concept. Cos A gone, and we are just left with cos A plus 1. Now I am thinking what to do with this cos A plus 1 to get that sine square A 1 minus cos A. Okay, so think about it. And if you can't do anything at all, then you are allowed to take RHS as well. And you can work with the RHS. Maybe from there also you will be getting the same thing. Even though this hint and all, it's not written in the question, and it will never ever be written anytime, anywhere. Still, when you are working with the LHS and you are not getting anything, the last step is cos A plus 1, and from there you don't know how to make it sine square A in the numerator, or maybe 1 minus cos A in the denominator. However, I can see how can we make the RHS. Okay, if you are feeling, then that's great. Okay, again we will be doing the multiplication numerator and denominator with 1 minus cos A, and we will be done with the proof. Can you see that? Can you see that? In your hand, you are having cos A plus 1. Okay, cos A plus 1 means 1 plus cos A. Yes or no?
Yes.
And if you will multiply 1 minus cos A in numerator and denominator, why we are going to do the multiplication? Because other side 1 minus cos A is there in the denominator. Okay, if you will multiply 1 minus cos A in the numerator and denominator sorted, and numerator will be A plus B, A minus B. That means this is square minus that is square, which eventually will be 1 minus cos square A, and will be sine square A. Making sense?
Yes, ma'am.
We will be done with the proof.
Yes, ma'am.
Okay, these things I am getting. But if you are not getting this all, then you are allowed to work with the RHS. Okay, you can go and take RHS, and now you can work on RHS. Maybe from there also you will be getting the same thing which you have obtained from LHS. So from LHS we have got cos A plus 1. Separately, if I will take RHS, that is sine square A by 1 minus cos A. This numerator in the RHS can be taken as sine square A, can be written as 1 minus cos square A by 1 minus cos A. The numerator can be written as A plus B, A minus B. We are not doing these things only in this question. Very often we are doing almost in every question. So I'm writing 1 plus cos in one bracket and 1 minus cos in another bracket, over 1 minus cos. 1 minus cos, 1 minus cos gone. And whatever result we have generated from RHS, can you see the same we have obtained from LHS, and we are done with the proof? Making sense?
Yes, ma'am.
Okay, so either you do this way, or after LHS getting the last step only, you can do the arrangement by yourself. Okay, you have to do the arrangement because now no simplification and all, nothing is possible. Clear?
Yes, ma'am.
Okay, so for doing this, all the arrangement, practice is required. Okay, you practice enough question. At least for now, just do this till question number 8 from the third exercise, including the examples before this exercise. Okay, where the proof based questions are there, and let me know if you are having any doubt anywhere. You can also start solving PYQ if you are really clear with this concept, and let me know the questions which is not clear to you, or maybe you have started solving but you got stuck. You can tell me the question, I'll take it over here, we can work on it together. Okay,
Okay.
Yes, ma'am.
so yes, today I'm keeping this much over here, and yeah, let's continue and finish this one in the next class. Till then, take care of yourself. Thank you. Bye.
Thank you, ma'am.
Thank you. Bye.